Experiment 4T1, Measuring Resistance of Thermal Insulation. Upon completion of this lab, you will be able to find the temperature on each side of an insulator and find the thermal resistance of an insulating material. The equipment that you'll be using will include the circuit panel easel, the circuit panel, the digital multimeter, the high voltage power supply. You've got a DP/DT switch. You got your heat transfer accessories, which includes the heater block, the heat sink block, and the insulating block. You've got a scaled thermometer. You've got two thermocouples and your universal lead set. Remember, this is what our thermocouple looks like. Thermal resistance is a measure of how material resists the flow of heat energy through it. As heat flows through a material, a temperature difference develops across the material that's proportional to the thermal resistance of the material. An insulating material has a high value of thermal resistance. A large temperature difference is required across it to produce a significant heat flow. Thermal resistance is the ratio of the change in temperature divided by the heat flow rate. And you have two main terms that you need to know: thermal resistance and insulating material. The thermal resistance is a measure of how the material resists the heat flow, and also the material, which is the insulating material, is part of it that resists the flow of the heat energy. In this lab, you will place a piece of insulating material between two conducting blocks. One block will be heated by the electric heater and insulated from the surrounded air. This heat will then be transferred to a second block called the heat sink block through the insulating material. The basic setup for this lab will be shown in this video. First, you're going to take your two power supplies and you're going to push them into the recessed hole on the heater sink, just like this, and turn them so that they don't block the recessed area that you're going to use in a minute. You're going to feed the leads of the thermocouple through the block hole as you're seeing done right now. And then it's going to go back into the heater in the hole that's there, like you see there. Procedure number 3. You're going to place the insulated material, which is a styrofoam block, into the lid cutout. You're going to put the silver part down. Then you're going to place the heat sink block on top of the insulated material. And then press it all in there. And you're going to insert the thermocouple from the bottom switch into the hole that you see here. And it goes all the way into it and sticks in place. In step 4, these procedures show how you're going to hook up your DP/DT switch. You've got across the top up here, this is connected to one of the thermocouples, and it's going into the bottom here, so that's this one. And you've got the other thermocouple that's going into the heat sink block right here. You're going to turn on your, connect your power supply, and you're going to turn this on VDC, and you're going to adjust this to 10 volts. In this lab, you're going to be taking the thermocouple reading without a reference junction, and the reference temperature will be the room temperature measured by your thermometer. You must add the measured probe voltages to the room temperature voltage. It's equivalent to get the total thermocouple voltage. this total voltage will determine the actual thermocouple temperature. You'll find the room temperature voltage in Table 1. That's this table. We've used this kind of data table before. So you need to record your power supply voltage and your current in your data table in the student journal. You'll read the room temperature from the thermometer, and you're going to record that in your data table. And you're going to turn on the digital multimeter, and you're going to adjust that so that you can measure millivolts. So you're going to connect it over here to the volts side, and you're going to set it on millivolts, which is this last little connection here, millivolts. Remember, millivolts means 1,000th of a volt. You're going to let this thing warm up for 15 minutes. So as this thing's heating up, you're going to 15-minute warm-up time. You're going to check the thermocouple probe voltage to see if it's stabilized. Remember that you're going to flip it back and forth to get the top and the bottom voltage, and when those voltages are about the same, then you've got a stable state. Record your values in millivolts in your data table, turn off the power supply, and take the lab apart. Then it's time for the calculations. Find the total temperature voltage by using the total thermocouple voltage from each block. And you do this by adding the room temperature voltage to the probe voltage, like you see in this equation. Record that information in your data table. You're going to use Table 1, which is the one that you just saw here, to convert your total voltage from millivolts to degrees of temperature. Record that in your data table. You're going to find the temperature difference across the insulating material, and to do this you subtract the heat sink temperature from the heater temperature. You're going to find the input heat flow rate of the thermal heater block in watts and joules, which are joules per second. To do this, you simply multiply the power supply voltage by the current, and then you convert the watts to joules per second by using the relationship for every 1 watt there's 1 joule per second. And here's your equation. Use the following equation to convert your heat flow value from watts to calories per second. So you're going to be multiplying your heat flow value times 1 and dividing it by 4.18 joules. Record that in your data table. The last calculation is following the equation that you're going to get the thermal resistance by dividing the change in temperature by the heat flow rate, and record that in your data table. Then you have some questions. You're going to answer questions 1 through 5 and submit your lab.